Hello everyone, today we'll talk about the solution to the problem construct string with repeat limit. In this problem the solution is going to be greedy, and in general whenever you are trying to construct the lexicographically largest or smallest string, the solution will most likely be greedy, and we can see why a greedy solution works here. We'll be building our string element by element. Of course, when it comes to lexicographically comparing, we want the string to be as long as possible and the characters to be as big, as late in the alphabet as possible, looking from the left. Then what should be the first element? Well, obviously the first element is the first element that we can put at that spot, so just the biggest letter. And so on for the second, for the third, and so on. At some point, the biggest element that we can put in that spot is not the biggest available character, because there would be a repeat. Okay, so we cannot put that character, but everything we did previously was certainly good. If we were to put previously something that's smaller than one of those characters, the solution would immediately be worse. And okay, so what should we put here now to avoid a repeat? Well, we should put the biggest character we can put now. So we should put the second biggest character of those available. And then we should put again the biggest possible character and so on. So at every step, we either put the biggest character or the second biggest character and then the number of repeats resets, and that's the whole solution. To maintain the available characters, instead of using a heap or something like that, we can simply use a sorted stack and pop and push elements on that stack, and then we can ensure that we don't have to skip multiple characters that do not exist. But that's just an implementation detail. So we start by counting every character. We use counter of s to count them. Items gives us an iterator over all pairs of value and the number of times it appears. We want it to be a list because it's going to be our stack. And we're sorting this stack because so this will be sorted increasing, in an increasing order, but that's good because we want to take elements from the back, because taking elements from the back using pop and push, or append, pop and append, is O of 1, while operating on the left end of a list is very slow. And our result will be building character by character. Here I have a sentinel value to make the code a bit shorter. And we'll also, of course, maintain the number of times we've used the last character. And now, while there are still some characters available, we'll be maintaining the invariant that any pair on our stack of element and count is only when count is positive. So that means that there are still some characters remaining. And you want to take the character that we have at the biggest character that's available, append it to the result. If the count is bigger than 1, we want to append also to the stack the same character with count smaller by 1, and of course we have to increase the number of times we've used that character. And now to ensure no repeats, we'll have to, first of all, if the character that we currently have is different than the last character in the string, then of course there is no repeats for us to care about. Otherwise, if we have reached the repeat limit, we have to put the second biggest character. So again, we have to take from our stack of available characters the second character with its count. So if nothing is on the stack, we have to break. That's the best string that we can generate. Otherwise, we append that value. We reset used to be equal to 0 because we have broken this repeat limit. Notice here that there will never be a case where we append character v2 from within this if statement, and then we append character v2 immediately as this v1 in the next iteration. That's because we only enter this if there indeed is some instance of the character v1 remaining. So we are sure that when we append character v2, that we will then append at least one more character v1, so we can reset the number of used characters to 0 here. And of course, again, if there is some remaining v2, we append it back to the list of available characters with one fewer occurrence. And at the end, we just take our string, remove this sentinel value, and return it as a string, and that's it.